Hello students, this is the second video that goes with the 55s. We learned that when we have an exponent, this exponent tells you roughly what the pH would be. So the pH in this case would be 12 or around 12. Now I'm going to show you how to do some math that's involved with this as well. So 23, what would be the pH of a strong acid with a concentration of 0.00100? So this is a problem that we just did. First of all, we've got to realize it's a strong acid, so that means it's going to break apart or dissociate 100%. So whatever the molarity of the acid, that would be the molarity or concentration of the hydrogen ion. The formula that we're going to use is negative log, and then multiply that by the concentration of the hydrogen ion, and that will give me the pH. So on your cover, we have that right here. pH equals the negative log of the hydrogen ion concentration. So buttons to push. Most likely, you will push the negative button, which is not the same thing as the subtraction button, the log button. You'll type in this 0.00100, or you can put it in this way if you want to put it in scientific notation. You will have to put it in scientific notation at some point in time on some of these problems. On some of our other brand calculators, this will be the way that you put it in. 1EE -3, so it's 1 times 10 to the negative third, and then you hit log. So that is a way of putting it in as well. Try that, see if you actually get the answer, which we know to be 3. If you don't get 3, things are not going well on your calculator. You need to play around a little bit or come in for some extra assistance. 24 would be the pH and the pOH of a strong acid with a molarity of 0.0330. Well, to write that in scientific notation, it's 3.30 times 10 to the negative second, so I know my pH should be somewhere around 2. This is a strong acid, which means it dissociates 100% into hydrogen ions and then whatever anion is left after that. My formula is pH equals the negative log of the hydrogen ion concentration. That's on your cover, and that is that one right there. pH, what is it going to equal to? Well, in my calculator, I'm going to go negative log, and I'm going to type in 3.30 times 10 to the negative second. When I do that, I'm going to get a pH. You should go ahead and try that on your calculator and see what you actually get. Hopefully you get 1.48. If you did it correctly. If you did not get that, you did something wrong. The next question is then, what is the pOH? Well, if it all has to add up to 14, based on that mathematical setup, I do some math, and I get the pOH to equal 12.5. We're going to 3 sig figs, and you'll understand more later on why we are doing that. Take some time to really make sure you're getting these numbers and how you use your calculator. Question 25. Suppose your pH is 4.58. Now calculate the hydrogen ion and hydroxide ion concentrations. So in this problem, we're going from there down to here, and then over to here. So to do that, the hydrogen ion concentration formula is right here. So the hydrogen ion concentration is equal to the 10N button, which on most calculators I believe is the second log button. And then I put in negative sign, and then I put 4.58. I hit enter on my calculator, and if I do it correctly, I should get a number. Again, the pH is 4.58. I should get a number with an exponent around 4.58. Punch that in your calculator. If you get 2.63 times 10 to the negative fifth for your hydrogen ion concentration, you did it correctly. The next setup goes to one of the first things that we taught you today, and that was to use this formula right down here on the bottom. So I know my hydrogen ion concentration, I know my 1 times 10 to the negative 14th, and I have to solve for my hydroxide ion concentration. If you do that correctly, your hydroxide ion concentration is 3.80 times 10 to the negative 10th. Again, make sure you know how to use your calculator. See if you're getting those same answers. If you're not, you need to come in for some help. 26 is where we're going to start doing some of the questions that are like the 60s. The 60s are your actual homework after I've taught you this material. So here we're going to use all 4 corners of this chart and all of these chemical mathematical setups. We're going to go with 3 sig figs with all numbers. Reason for that: if I'm going from hydroxide up to pH, if I go up, I'm using multiplication division. If I go over, I'm using addition and subtraction. If I go this way, I'm using multiplication division. If I go up, I'm using multiplication division, and the rules would be different. So if we all go to 3 sig figs, then our answers should be all pretty similar to each other. So that's why everything on here is going to be 3 sig figs. And we're going to use scientific notation for the hydrogen ion and hydroxide ion, so we can look at those exponents and see if they get close to our pHs. So for question 26, it gives us this molarity of this acid. This is a strong acid, meaning it's going to break apart completely, which means that the molarity of this acid is my hydrogen ion concentration. So I go over here and I write in my hydrogen ion concentration, but I do it in scientific notation. So that's 4.00 times 10, and I have to go to the negative second. So I have this. Now I'm going to go up and I'm going to get my pH right away. pH is equal to the negative log of that number. My pH should be around 2 because the exponent is 2 there. If I use this particular setup right here correctly, I end up getting 1.40 as my answer. Now I'm going to do my POH. pH plus POH equals 14. So I do my subtraction there, and I get 12.6. When it asks for acid, base, or neutral, I look at the pH and only the pH. pH and POH are opposites of each other. So I only look at the pH. I see that it's below 7. Anything below 7 I know to be an acid. And then the last thing I need is my hydroxide ion concentration, and I'm going to use this formula right here on the bottom. I know my hydrogen ion concentration. I know the 1 times 10 to the negative 14th, so I solve for my hydroxide ion concentration. Now, depending on how you go, you could get 2.50 times 10 to the negative 13th, or if you were up here and you got your POH and you decide to go down, you would get 2.51 times 10 to the negative 13th. Either one is fine, and we'll give you multiple answers on the answer key depending on which way you use this chart. Let's look at a couple things. Our hydroxide ion concentration has an exponent of negative 13. That means it should have a POH that's close to 13. Hey, and that's 12.6. My exponent here is a 2 negative, so my pH should be around a 2. And it is around a 2. pH and POH should add up to 14. Sometimes it might be slightly above, sometimes it might be slightly below, but it should all come out pretty close to 14. And these two exponents, this 2 negative and this 13 negative, when we add those two together, we should always get around 14. Now, this is a little different. They could add up to negative 13. They could go all the way up to negative 15. It just depends on these numbers out in front and how they affect everything. But those two exponents right there should get you close to negative 14. I have that all here, and it's also below your chart. Those are some little ways of checking your answers. So that's what I just gave you. Go ahead and solve the next one. Pause the video, and then I will give you the answers. There are the answers to 27. Pause the video, try 28. And there's 28. Pause the video, take a look at those things. And I'm going to go over this little part that's at the bottom. pH and pOH should add up to roughly 14. These exponents should roughly add up to negative 14. This exponent of negative 14 gives me a pH that should be around 14. This exponent of negative 1 should give me a pH of, or a pOH, excuse me, of around 1, and that does. Your homework is the next page, which is the 60s.